Okay, so now we're ready to name and write ionic formulas. So we're going to name, we're going to be given an ionic formula and we're going to find the name, or we're going to be given the name and we're going to find the formula, right? So our learning goal is, as I said, our learning goal is given the formula, write the name, or given the name, write the formula. Okay, so when naming an ionic compound, the name of the metal is written first, and it's the same as the name of the element. We sort of already ready for that, right? The name of the nonmetal is given second, and we change the ending to "ide." Right, and we put a space between the name of the metal and the nonmetal. So here's some examples. Here's our compound. The metal is always going to be given first. The metal is potassium, and the nonmetal is iodide, and so its name is potassium iodide. Magnesium is the metal. Bromide is the nonmetal, and so its name is magnesium bromide. Aluminum is the metal. Oxide is the nonmetal, right? There's aluminum, there's oxide, and so its name is aluminum oxide. All right, it's that simple. So let's do one here. We have, looks like that's potassium. I gotta figure out how to write my U's. Potassium, and there's oxygen, and don't forget we get rid of the ending and we change it to oxide, and so its name is potassium oxide, and that's it. All right, so let's run this out with a learning check. Please pause the video, generate answers for these, and then come back and compare your answers to mine. Okay, so I'm going to suppose you did it. I looked this up right now, and this is calcium. Calcium. Oxygen. And I get rid of the ending and make that calcium oxide. Okay, so let's do another one. Aluminum. Oxygen. And the ending gets to oxide. Aluminum oxide. And then finally, we have magnesium, right? And chlorine. And I changed the ending of the last one to magnesium chloride. And that's it, okay? So let's practice now our charge balances. So if you're asked to write the formulas and names for the compounds of the following ions, pause the video and give answers for this and see what you get. Okay, so I'm going to suppose you paused it, and I see this is 1 to 1. There's a sodium plus 1 and a bromine minus 1, so it's going to be NaBr. I'm not going to name it. I'm not going to write it out here, but it is sodium bromide. Okay, now if we have a plus 1 and a minus 2, then that's going to be, it looks like it's going to take 2 plus 1s, right, to match up with a 2 minus. And so it's going to be sodium sulfide. And then finally, I have a plus 1 and a minus 3. So it looks like it's going to take multiple plus 1s. How many? Well, 3, I guess, right? To account for the 3 minus. And so that's going to be sodium nitride. All right, let's come down here. Aluminum is 3 plus, and that bromine is minus 1. So it looks like it's going to take 3 bromines to make, oops, no, I said 3 and wrote 2. It's going to take 3 bromides to account for the plus 3 aluminum, right? And there it is, and that's aluminum bromide. Okay, and then a plus 3 and a minus 2, the lowest common multiple is 6, so it's going to take 2 aluminums to get 6 plus, and it's going to take 3 sulfurs to get to 6 minus. And so this is going to be aluminum sulfide. And then finally, a 3 to 3, that's just going to be aluminum nitride, right? Because their lowest common multiple of 3 and 3 is 3, right? So it's only going to take one of each of those to make an even compound. That's it. Okay, so the next kind of ionic compound we have to worry about are compounds that have metals with variable charge. So transition metals, I got my periodic table right here. All this blue, all this stuff here, this stuff all here is transition metals, okay? This is not. This is group 1 and group 2, our main group. And these are main groups over here. But transition metals over here have variable charges. That is, we don't know by looking at the periodic table what their charges are. So we say copper, for example, could be +1 or +2. And you don't know which it is, right? You have to be told. So iron could be +2 or +3. Lead could be +2 or +4. And there's no real trend here. Chromium could be +2 or +3, right? Now, there are some transition metals that we have to memorize that only have 1. Silver is always +1. Cadmium is always +2. Zinc is always +2. Okay? But the ones that have variable charges, we have to say what their charges are with the Roman numeral. So if I see a copper 2+, I call it copper Roman numeral 2. All right? So otherwise, our rules are going to be all the same. Now, table 6.6 from your textbook shows a good list of lots of metals that have variable charges. Bismuth could be +3 or +5. Chromium could be +2 or +3. Okay, again, you don't need to memorize these. You just need to know that they could have variable charges, and we'll figure out with the information we're given in the question what they are. Here's an example. Suppose you've got MnF2. Well, manganese is right here, right there with the transition metals, right? So you don't know what its charge is, but you do know what you do know what fluoride is. You know what that is. Fluoride is a -1, and you've got 2 of them, and you know that they come out to be 0. So what must manganese be? It must be +2, right? Because +2 plus -2 gives 0. And so consequently, it is manganese 2 fluoride. All right, so let's go back over here. This, just to remind you, zinc is always +2, silver is always +1, and cadmium is always +2. By the way, this is a neat little trend here. +1, +2, +3. That could maybe be a good way to memorize that. +1, +2, +3. Those 3 right there could be easy to memorize, all right? But all these other ones, these other metals in here have variable charges. Now, these do not have variable charges because they're in the S block. Those are called main group metals, right? And so they always have plus, 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 or 2 plus 2 plus 2 plus 2 plus, right? All right, so let's do an example. Naming the ionic compound I almost named it, FeCl2. All right, so first of all, it's going to be iron. And it's going to be chlorine, right? But we got to change the name to chloride. All right, but since iron has variable charges, because it's right here in the middle of the periodic table, then we got to say, well, how many is it? Well, I'm going to take my FeCl2 and make some notes here. This is always -1, right? But there's 2 of them, so it's going to be -2 total, and it's got to balance out. So whatever iron is, it's got to balance out with a -2 to give 0. Because see, there's 2 -1s here, right? So that's -2. Aha, it's +2. Okay, and so the name of this is iron 2 chloride. That's the name of it. All right, so let's give you a chance to practice. Pause the video and do this compound, and then compare your answer to mine. Okay, so I'm going to say 10. It probably has a Roman numeral. I'll come back over here to this table in a second. For now, 10 oxygen, right? But this gets changed to oxide, so it's tin oxide. Let's go back over here, and sure enough, tin could be either 2+ or 4+, right? So let's go look at it. It's a transition metal, and so let's look at it. Wrong slide. Let's go over here. Well, we know that SnO2. We know that oxygen is in group 6, so it has to be it wants to be a -2. -2 times 2, it's going to be a total of -4, right? It's going to be a total of -4, and so it looks like the tin must be +4. And sure enough, it is tin 4 oxide. All right, let's move on. Writing formulas for the name of an ionic compound. This is even easier. The formula for an ionic compound is written from the first part of the name that describes the metal and the second part that specifies the ion. And the subscripts are added to balance the charge. Okay? So let's, like for example, iron 2 chloride, if I'm given iron 2 chloride, I know this must be a +2, right? Let's do an example. Iron 3 chloride, oh, there you go. Iron 3 chloride, so it must be iron 3 plus and chloride. So how do these guys match up? Well, we've already matched these up before in a previous exercise, right? 3 plus must be 3 of these. So it's going to be FeCl3. Okay, so let's round this conversation out with a little learning check. Pause the video, write some answers out, and come back and compare your answers to mine. Okay, so first of all, let's do this one. I'm not sure what I was doing there. Started by being an arrow. Let's come here and say nickel 2. It's going to be nickel 2 plus, right? And sulfide, which is 2 minus. And how are these guys going to match together? Aha, they have the same charge, same magnitude. So this is just going to be 1 to 1, nickel sulfide. Okay, zinc chloride. Now zinc, I've got that memorized, is always 2 plus. And chloride is always 1 minus. And so it looks like it's going to take 2 of these to match up with that 2 plus. So it's going to be Cl2. Okay? And let's do iron 3 oxide now. Iron 3. I didn't leave myself much room, did I? Iron 3 plus. And oxide's always 2 minus. Right? So it looks like the lowest common multiple of 3 and 2 is 6. So it's going to take 2 of these and 3 of these to make the charges match up, right? So it's going to be iron 3 oxide is Fe2O3. All right, hope that's helpful. We'll get some more practice in our homework.